look at the triangle count. Now look at this. Same world, same blocks, same textures. This is what face culling does, and this is how we built it from scratch inside a single combined mesh. Every cube has 6 faces. In a solid chunk of blocks, the faces between two adjacent solid blocks are completely invisible. You will never see them. No player will ever see them. But without face culling, we were regenerating and rendering all of them anyway. In a 20 by 20 chunk with 40 blocks of height, that potentially tens of thousands of invisible triangles per chunk. Multiply that by every chunk in the world, and you're rendering a staggering amount of geometry that contributes absolutely nothing to what the player sees. The rule is simple. If a block's neighbor is solid, the shared face doesn't get generated. Only faces that touch air or the edge of the chunk make it into the final mesh. Everything else simply doesn't exist. The result looks exactly the same from the outside, but the geometry is a fraction of what it was. Here's where it gets interesting. In a traditional voxel engine, each block is its own object. Checking neighbors is straightforward. Just check the adjacent game object. But we combine everything into one mesh per chunk. There are no individual blocks to query. We had to build the neighbor check entirely in data. The chunk stores a 3-dimensional array of block types: air, surface, subsurface. Before adding any face to the mesh, we check the neighbor in the direction inside the array. If the neighbor is a solid block, we skip the face entirely. If it's air or outside the chunk boundary, or above the world height limit, we add the face. 6 direction, 6 check per block: south, north, bottom, top, west, east. Each direction has a predefined offset vector. We iterate through every non-air block in the chunk. Run all 6 check, and only call add face data for the face that actually need to exist. The chunk boundary case is important. If a block sits on the edge of a chunk, and its neighbor would be in the adjacent chunk, we treat that as transparent for now. Inter-chunk culling is a future problem. For now, edge faces always render, which is correct behavior. They are visible from outside the chunk. Face culling itself was relatively clean to implement. What wasn't clean was getting the texture to look right afterward. And this is where the single combined mesh made everything significantly harder. With individual block game objects, Unity handles the UV mapping automatically. Each prefab has the UVs baked in and the renderer just uses them. When you build face programmatically inside a combined mesh, you are responsible for every vertex and every UV coordinate yourself. Our blocks have pixel art textures. Different faces of the same block can have different parts of the texture. The top of a grass block looks different from the side, which looks different from the bottom. We needed to correctly map each generated face to the right region of the source texture. The solution: we read the UV data from the original block prefab and built a mapping table. Each of the 6 face directions maps to a specific UV index in the prefab's mesh data, with an additional rotation of set, because generated faces and prefab faces don't always have the same vertex winding order. Getting that rotation table right took a while. A face that looks correct from one angle looks completely wrong when you're looking at it from the opposite direction. The texture's title backwards or rotate 90 degrees. We ended up with explicit rotation values per face direction. Not elegant, but correct. With the geometry count under control, we could finally push the world size to something that actually feels like a world. Previously, 20 by 20 chunks, 40 blocks of height. Now the height limit is 140 blocks. 140 blocks of vertical range means real mountains. No gentle hills, actual peaks with rough rocky faces near the top, and smooth terrain at the base. Exactly as the roughness parameter in the biome data was designed to produce. You can stand at the bottom of a valley and look up at something that generally feels tall. The chunk closing keeps generation smooth. The world builds chunk by chunk in front of you without freezing. With face culling reduction geometry per chunk, the generation path itself is also faster because we write in fewer vertices to fewer lists. The UV rotation mapping. The vertex winding order for generated faces doesn't match the winding order in the original prefab meshes. So even when we pull the correct UV coordinates from the prefab, they were being applied to the wrong vertices. The texture was technically correct, but rotated. Fixing it meant building an explicit rotation offset table per face direction and applying it when sampling the UV array. Face culling is one of those things where the result is invisible. The game looks exactly the same, it just ran properly. The triangle count is down dramatically. The wall height is at 150 blocks, and the textures are finally mapping correctly, on every face, in every direction. 140 blocks, and the textures are finally mapping correctly, on every face, in every direction. Subscribe if you want to follow it. See you Thursday.